Today we're going to start learning about a concept that you've heard mentioned before, and it's the mole. Okay? It is not the creature that lives in the ground, but it's going to be a unit that we're going to use from here until the end of the course. The purpose of the mole is because atoms are so tiny, we needed some sort of unit that would be measurable to be able to deal with looking at substances, because we can't deal with them in terms of atoms because they're just too small. So scientists went and figured out they got pure carbon-12, which means carbon-12 with no other isotopes, and they got 12 grams of pure carbon-12 and figured out how many atoms were in that sample. And that sample is the basis for our unit, the mole, and that number, which you need to know, is 6.02 times 10 to the 23rd. So when we look at the definition of the mole, 1 mole is equal to 6.02 times 10 to the 23rd units of that substance. And I can write it like this as well. It can be any substance. It's the same as using the word dozen. So if I ask you to get a dozen pencils, you know that that means 12. We think of eggs in terms of dozen because they're sold in groups of 12. But if I told you to get a dozen bagels, you would know that would mean to get 12. And if I told you to get a dozen crayons, you would know that that would mean 12 as well. Well, if I asked you to get a mole of pencils, you would get 6.02 times 10 to the 23rd. And if I asked you to get a mole of donuts, that would be 6.02 times 10 to the 23rd. When we're going to use the mole in calculations, a sample of an element with a mass equal to that element's gram formula weight contains 1 mole of atoms. So basically, we learned how to do gram formula weight. We learned how much each compound weighs and how much elements weigh. And if we can solve that gram formula weight, that's equal to 1 mole. There's some other conversions that we can use. We can also say that 1 mole is equal to 6.02 times 10 to the 23rd particles. And we can also say that 1 mole is equal to 22.4 liters of a gas at standard temperature and pressure. We'll worry about the standard temperature and pressure part when we get to gas laws, but for right now we're going to assume everything is at a standard temperature and pressure. So we're just going to use 1 mole is equal to 22.4 liters. So looking at just some basic questions without calculating, just so we can get some understanding on this mole, what does 1 mole of magnesium weigh? Well, to find out what 1 mole of magnesium weighs, you're going to look at the periodic table. And if you don't have one out, I suggest you get one out so that you can refer to it while we go through this PowerPoint. But 1 mole of magnesium is equal to the gram formula weight. It's 24.30 grams. What does 1 mole of sodium chloride weigh? Well, in order to figure out what 1 mole of sodium chloride weighs, we need to add up sodium, which is the 23, and we need to add up the chlorine, which is the 35.45. And so if we do those calculations and we add them together, we get 58.45 grams. And then if we think about this another way, what does a half a mole of calcium weigh? Well, according to the periodic table, 1 mole of calcium weighs 40.08. So a half a mole of calcium weighs 20.04. I just divide it by 2. And then looking at the particle questions, how many particles are in 1 mole of lithium? Well, 1 mole of anything has 6.02 times 10 to the 23rd particles. How many particles are in 1 mole, or how many particles are in 58.45 grams of NaCl? Well, 58.45 grams of NaCl is 1 mole, because that's what 1 mole weighs, and 1 mole has 6.02 times 10 to the 23 particles. That means we have 6.02 times 10 to the 23rd NaCl molecules. And then how many liters are there in 1 mole of argon? And argon is a gas. It's a noble gas. And so we're only going to use liters, not in terms for anything liquid, only for gases. But so 1 mole of argon would contain 22.4 liters. And so a great summary of all these relationships is 1 mole is equal to 6.02 times 10 to the 23rd particles. is equal to the gram formula weight is equal to 22.4 liters of a gas at standard temperature and pressure. So that means since they're all equal to each other, they're all, you can say 1 mole is equal to 22.4 liters. You could say gram formula weight equals 6.02 times 10 to the 23rd particles. They're all one big equivalent. And we're going to do calculations on the next couple slides, just like we did in the beginning of the year. We did some dimensional analysis where we converted from centimeters to meters and inches to miles to kilometers. And the reason we did that was to set up how we're going to do these calculations. This is the basics for stoichiometry. So again, I'm going to be pretty particular as to how I want the work to look. But that's going to help you when we get to the more complicated material. So how many moles are there in 10.68 grams of iron? We can't just stay with simple whole numbers. So we're going to set this up just like we did before, 10.68, and we're going to be particular. We're going to write grams of Fe. I know you're like, well, iron's the only thing in the problem, but we're going to get to things that are more difficult and have multiple chemicals, and so I'm setting you up to make this easier down the road. If we want to get rid of, oops, sorry, come back here. If we want to get rid of grams, we're going to put grams on the bottom. And if we want to convert to moles, we're going to put moles on top. Grams of iron, according to the periodic table, are 58.85. And that's what its molar mass. And then when I calculate it, I get 0.1912 moles of iron. And that's important to have all of those labels that I have on there. Grams of iron, moles of iron, and be very specific like that. I will be looking for that. Now, how many moles are there in 25 grams of NaCl? Well, 25 grams of NaCl. Again, I want to get rid of grams. Grams of NaCl goes on the bottom. 1 mole of NaCl goes on top. And, gosh, I keep hitting that. And earlier, we saw that there was 58.45 grams of NaCl in 1 mole of NaCl. That's the formula weight. So it's equal to 0.4277 moles of NaCl. Notice I'm following my significant figures. I have 4 in my question, so I have 4 in my answer. And remember, you get plus or minus 1 significant figure. How many particles are there in 23.55 grams of gold? So let's look at this. Now we're using grams and particles, but they're equivalent as long as we use gram formula weight. So 23.55 grams of Au. I want to get rid of grams. I'm going to put grams on the bottom. I want to convert to particles, which is our word that we use because it means both atoms and molecules. And so particles, we don't have to switch between using them properly. We can just use particles for all of them. Grams of Au, I'm going to look at my periodic table. It's 196.97. And my particles is 6.02 times 10 to the 23rd. Also in the beginning of the year, we learned how to use that EE key. And so that's going to be important when using this in your calculator. So when you punch that into your calculator using that E key, you get 7.198 times 10 to the 22nd particles of Au. And I'd like you to punch that into your calculator to make sure that you do indeed get that answer. Another question, how many liters are there in 2.5 moles of krypton? All right, again, krypton's a gas. It's one of our noble gases. So we have 2.5 moles of krypton. And we're going to do 1 mole of krypton on the bottom. That's what we're getting rid of. And we're going to put liters on top. Our liters that we're going to have is 22.4 liters of krypton, because that's our conversion. And we end up with 56 liters of krypton. And now looking in the opposite direction, if we have moles and we want to convert to grams, okay, we have 4.56 moles of LiF. And we want to get rid of moles, so I'm going to put moles of LiF on the bottom, and I'm going to put grams of LiF on the top. And now I have to go and do my formula weight, so I list them, I count them. At this point in the year, it is fine for you to just fill in the numbers. You do not need to show the work that I'm showing here. I'm just showing in case people aren't realizing where I'm getting the numbers from. So you're fine to just go ahead and write your gram formula weight right in there. But I didn't want to leave people hanging in case they didn't realize where these numbers came from. So just from the periodic table, I got the 6.94 for Li. The 19 I got from the periodic table. There's one of each of them. I multiply them, I added them down. So 25.94 grams is my formula weight. And then when I calculate this, I get 118 grams of LiF are in 4.56 moles of LiF. And just so you can get an idea of how big a mole really is, just a couple of statistics. A mole of seconds is 4 million times as long as the Earth has existed. So it's a really big number. And 1 mole of marbles would cover the entire Earth 50 miles deep.